When an acid dissolves in water, a hydronium ion is born. Let's build it step by step. Start with water. Oxygen shares an electron pair with each hydrogen. But oxygen is more electronegative, so it pulls those shared electrons closer. That makes each bond polar covalent. Since the electrons drift toward oxygen, the oxygen end turns slightly negative, delta minus, and each hydrogen slightly positive, delta plus. Water is a polar molecule. Now look at the oxygen. Besides its two bonds, it carries two lone pairs electrons all its own. Remember them. They do all the work. Here's our acid, hydrogen chloride. Its bond is polar too. Chlorine pulls the electrons, so hydrogen becomes delta plus and chlorine delta minus. Drop it into water. The polar water molecules crowd around and pull hard on the weak bond, stretching it more and more until it snaps. Chlorine leaves with both electrons as a chloride ion. The hydrogen is left as a bare proton, an H+, with no electrons at all. But the bare proton is tiny and intensely charged. It cannot exist alone in water. It is desperate for electrons. And water has exactly what it needs. A lone pair on oxygen reaches out and bonds the proton. Since both electrons come from oxygen, this is a coordinate or dative bond. The result is the hydronium ion, H3O+, 3 hydrogens on one oxygen, carrying the positive charge the proton brought. So the real reaction is this. Hydrogen chloride plus water gives a hydronium ion plus a chloride ion. The H+ never travels alone. This is the modern idea of an acid. It releases hydrogen ions in water, which instantly join water molecules to form hydronium ions. Those make the solution acidic. A polar bond, a lonely proton, and a generous lone pair. Together they build the hydronium ion.